Hello, and welcome to the session Deploying ArcGIS Enterprise in Microsoft Azure. My name is Nick Shampur, and I will spend the next 30 minutes talking about deploying ArcGIS Enterprise in Microsoft Azure and what's new and what has changed with the latest release of ArcGIS Enterprise. Along with me is my colleague Shailesh Goel, who's the lead developer on the Enterprise from Azure and Cloud team, who will be doing parts of this presentation as well. So the agenda for today is to start by giving you an overview of the ArcGIS Enterprise on Azure strategy. We'll follow that up by describing some concepts that will help make some of these clear to you. We'll follow that up with a what's new, describing some architectural changes that happened at the 10.8 release that we've fielded questions about through the calendar year of 2020. Then we'll discuss what's new since the last time we met, which is the two releases, the 10.8.1 and the 10.9 release that's coming up soon. We'll follow that up with some demos of using Cloud Builder and our automation technology. And we'll finish up with some tips and tricks to help you navigate the Cloud Builder tool. We'll start off with a quick overview. So our mission statement really is as follows. Our objective is to make deploying and managing ArcGIS Enterprise on Microsoft Azure as seamless as possible. What do we mean by that, and how do we achieve that? We do that by providing you with virtual machine images that are available in the Azure Marketplace. And by making it available in the Azure Marketplace, they are now available in all public Azure commercial regions. So that includes the 54 regions that are live as of today. It also includes the US GovCloud, commonly known as Fairfax. So these are the regions and the Azure infrastructure where these virtual machine images are available. To complement those virtual machine images, we provide easy to deploy and manage technology. And this comes in the form of deployment tools, which we'll discuss in this presentation. The first is a tool called Cloud Builder, and the second is various options for automation. Now, why is this such a big deal and why is this important to our customers? By providing this tooling, we actually allow you to not worry a lot about Azure constructs like resource groups and load balancers and network traffic rules and dividing your virtual network and worrying about SSL certificate configurations and Azure native terminology like key vaults and Active Directory. Right? We abstract all of that away for you by providing these easy to use tools. The first one is the Cloud Builder tool, also known as the ArcGIS Enterprise Cloud Builder for Microsoft Azure. It is a desktop application for Windows. It provides a wizard-driven experience to do your deployment and post-deployment workflows. Along with it, we're able to configure Azure native features like Azure Managed Databases, including Azure SQL Database, Azure Database for Postgres, and Azure SQL Managed Instance. Cloud Builder also has some integrations during deployment time with things like the Azure Key Vault. Additionally, ArcGIS Enterprise can work with your data not just in managed databases, but also object stores such as the Azure Blob Storage. Additionally, Cloud Builder can help configure your deployment to work within an Active Directory environment, such as Azure Active Directory, domain services. With an overview of our strategy, now let's shift and talk about concepts and site deployments. As some of you may be aware, ArcGIS Enterprise is a distributed system and comprises of these sites, which are commonly referred to as server sites. The first component is your portal for ArcGIS, which runs on your hosting server site. Additionally, you have server sites that play role-based functionality. Examples of this include a server role, the image server role, or the GeoEvent server role, or a GeoAnalytics server role. You may also have general purpose servers, in this case depicted with the GIS server site. Additionally, you can have data stores of various forms. This includes the ArcGIS Relational Data Store, the Tilecache Data Store, the Spatiotemporal Data Store, and any additional big data file shares that you may have and may want to connect as part of your WebGIS deployment. Now let's look at deployment options. You have the ability to deploy all of these components on a single machine or multiple machines. Or additionally, you can split the workloads up into different tiers, where you can have the portal component run on one tier of machines, and you can have the hosting server and the data store run on additional machines. In addition to the number of machines, you can choose where to store your configuration for your site. This could be on a regular VM as a file share, or could be in Azure Blobs and Tables, or it could be in Azure Files as well. Now, over time, we have evolved Cloud Builder to we evolved the architecture for Cloud Builder. And there was a significant deployment architecture change that was made at the 10.8 release. And I'd like to describe those and do comparisons with the version 1 and the version 2 artifacts. The big change at 10.8 is now for all your server sites within a WebGIS deployment, there's a single hostname or a single endpoint for access through basically a single fully qualified domain name. And what the advantage this gives you is you're now able to have that centralized endpoint to access all of your sites. For achieving this, we use the Azure Application Gateway, which acts as a layer 7 load balancer. And it has the ability to route requests based on the URL path, which is often referred to as the site context in ArcGIS Enterprise terminology. The Azure Application Gateway now provides us the ability to use the Web Application Firewall, WAF, and other security features. It provides us the ability to use Azure Monitoring and traffic analysis tools. And another convenience is now you can now use a single TLS certificate, which doesn't have to be a wildcard for the entire set of domains. And this was a popular ask from many a customer. Now let's look at this visually and understand what these changes are. In the version 1 architecture, this is what a site deployment would look like of WebGIS. The rectangle on the left, you have the hosting server with the components, the portal, the hosting server, and the data stores. On the right, you see individual boxes representing optional server roles that you may have with this site. All of these server roles are federated. And what's important to call out here is each of those server roles is accessed using its unique fully qualified domain name, or each service is accessed using a different host name. In the version 2 deployment architecture, you get a single fully qualified domain name to access all your federated ArcGIS server roles. So the /portal would take you to the portal component, /server takes you to the hosting server, /image takes you to an image server, /geoEvent to the geoEvent server, and so forth. Now you understand the convenience of having a single endpoint and accessing all your sites just by using path suffixes. Let's dig in a little deeper to understand these deployment patterns. Let's start with the single tier base deployment. In the version 1 architecture, where this was all those components were on a single tier, you had the portal component and the server component all running on the same machine and accessed via an external load balancer. In the version 2, you would see no change. It's just that the load balancer from a layer 4 load balancer is now the Azure Application Gateway, which is a layer 7 load balancer. Now let's take a look at how your base deployment has changed from the version 1 architecture to the version 2. In version 1, we used the layer 4 load balancer as your external entry point. In addition, we used a couple of internal load balancers to route traffic between the portal and the hosting server. This now changes in the version 2 architecture, where the proxy tier is now eliminated and the Azure Application Gateway can now route traffic to either the portal or the hosting server based on application or site context. Let's take a look at an example of a deployment of a server role. Let's start with something like imagery. In the version 1 architecture, you would have different endpoints for the base deployment or your hosting server. and you'd have additional endpoints with unique host names for the image hosting server and another for the raster analysis server. In the version 2 architecture, you would access all of those sites through the same endpoint or host name, and you could access the image hosting server or the raster analytics using the site context, in this case represented as /raster analytics or /image. Taking another example, let's look at example for a real-time GIS deployment using GeoEvent and GeoAnalytics. In version 1 again, you would have separate endpoints for the base deployment, the hosting server, and also separate ones for GeoAnalytics and GeoEvent. And you'd access them with different host names. In the version 2 architecture, you can access them with the single host name and then use application context like /GeoAnalytics and /GeoEvent to access the appropriate site. With that, I'd like to stop and hand it over to Shailesh, who will do a quick demo of basics of using Cloud Builder 10.9.
Thank you, Nikhil. Hello, everyone. I will start my demo by opening up the upcoming ArcGIS Enterprise Cloud Builder 10.9 for Microsoft Azure. I will click on the Sign into Azure button and will be presented with a pop-up that will ask me to select an account with which I want to log in. After the successful login, I will be presented with a list of all the Azure Active Directory tenants that I have access to. This is something new at 10.9 where we allow the user to pick a tenant. This behavior is a little different from the previous versions of the Cloud Builder, where you were assigned into the default tenant and all your subscriptions in that tenant would be listed. Moving forward, I select the tenant and will get a list of all the subscriptions that I have access to and can work with. Selecting one of the subscriptions, I'm shown a page where I get a list of all the ArcGIS Enterprise version 2 sites. On this page, I have quite a few options. I can choose to deploy a new site. I can manage my existing version 2 sites with base deployment and its associated federated servers. I can choose to view my ArcGIS version v1 sites and choose to manage them. I can also take a look at my ArcGIS desktop deployments. Coming back to ArcGIS version 2 sites, some of the manage operations that we support are manage machines in site, add a server machine to the site, or add a portal machine to the site when it's a max HA deployment, add a data store machine to the site, add a database or an EGDB to a standalone GIS server or one of the federated role-based servers. Upgrade your deployment from one of the previous versions of ArcGIS Enterprise deployed using Cloud Builder. We support for V2 version sites, we support from 10.8 and 10.8.1. For V1, we support right from 10.6 up till 10.9. Coming back to V2, we also support the ability to RDP to an existing site or delete a site. Before we move forward, I would like to make a note that starting Cloud Builder 10.8, we no longer support creating of new version 1 sites. To showcase how all of this works, I will walk you through the workflow to deploy a new site. In this workflow, you will be first asked to choose whether you want to deploy an base ArcGIS Enterprise site or any of the role-based servers. The role-based servers are the GeoEvent server, the GeoAnalytics server, the image server, the notebook server, the mission server, or the general purpose GIS server. In the WebGIS deployment pattern, you would ideally want to start with the base ArcGIS Enterprise site, which I do by selecting the first option. Next, I will be asked to choose a Azure resource group. You can think of Azure resource groups as a folder where you organize or group your Azure resources. You can also assign access-based control rules to these resources using the Azure portal. One pattern that is consistent throughout Cloud Builder is that either you can choose to create new resources or reference existing ones. Here I choose to create a new resource group. Once the resource group has been created, you will need to choose a VM image that you would like to work with. You can choose the Esri ArcGIS Enterprise 10.9 Marketplace image and the region you want to deploy this image to. Alternatively, an advanced user who has organizational requirements around security or wants some data as part of these machines when they start up can choose one from all the images in the selected subscription built and customized using ArcGIS Packer templates provided by Esri on GitHub. The next set of options will allow you to choose whether you want to deploy the single tier deployment with one or two machines or a multi-tier site with each of the components of the ArcGIS Enterprise stack on multiple machines. For now, I will check the single tier deployment, which is essentially your server, portal, and the data store running on a single VM. As part of the single tier deployment, you can choose to add another machine which might be required for additional capacity, resiliency, etc. As for multi-tier deployments, we will come back and talk about this in a little bit. On clicking next, you will be asked to select a bunch of networking options. First, you will be asked to pick a virtual network. Machines and other resources like App Gateway within Azure need to talk to each other. So they are always deployed to a virtual network, which is how machines join a machine with your enterprise. You can reference existing virtual networks or create a new virtual network. As part of the options, you will be required select two subnets. One that will be used by your virtual machines and the other one that will be used by your application gateway. For the purposes of this demo, I choose to select an already created virtual network which has a default subnet and an application gateway subnet. Next, you will be asked to select an IP that needs to be associated with your app gateway's front-end listener, which is essentially detecting incoming requests and routing them as required. You can either choose to reference an existing public IP which has a domain already associated with it, or choose to create a new public IP with a domain through which you would like to access the site. At 10.8, we also introduced the ability to choose a private IP from the application gateway subnet as your front-end listener, which will allow you to traffic from only within the network. For the purposes of this demo, we select the new public IP and click Next. After clicking Next, the Cloud Builder will ask you to provide an SSL certificate that needs to be installed on the application gateway's front-end listener. You can either choose a self-signed certificate that is generated by the Cloud Builder as part of the deployment, or you can use a trusted certificate issued by the certificate authority. In the latter case, you will need to provide the CNAME or the domain alias for the certificate, the PFX certificate file, and the password associated with this certificate. If you specified a private IP in the previous screen as your front-end listener, you won't be able to use a self-signed certificate and will have to provide a certificate issued by a certifying authority. For the purposes of this demo, we'll use a self-signed certificate and click Next. Moving forward, Cloud Builder will ask you specific questions about your machine. First is the credentials for the machine administrator account, which is required by Azure in order to provision the machine. Next is to select the size and the type of machine you would like to deploy. You can do so by clicking this pencil button. Here it will give you the type of OS disk you want to use, the machine types available to you in the subscription, the size of OS disk, whether you would like to add a data disk, the type of data disk you want to add, and the size of the data disk. Once you select all these options, hit apply. A bunch of additional options are provided to you, like selecting the time zone associated with the VM, whether you would like to join it to an Azure AD domain, enable automatic system updates, the name of the VMs for the primary and secondary machine, a daily automatic shutdown schedule that will be managed by Azure, whether you want to enable remote desktop access using a separate jump box on the port 3389. Once you have selected all these options, click Next. On the next screen, you will be asked to select one or more from the three types of built-in ArcGIS data stores. The relational data store, which is used to store the feature data, the tile cache data store, which are used to host the scene layers, and the spatio-temporal data store, which is used for archiving the real-time geo-event data and store outputs from the geoanalytics server tools. Once selected, hit Next. Here, you will be asked to provide some information related to licenses and credentials that is needed for the deployment. First, it asks for the license file for the portal and this server, which I already have on my local machine and will browse to now. Once I've selected the portal license, I will also be asked to select a user type. Here I select the creator user type. Next, I select the server license type. Next, I will be asked to give a primary site administrator and an ArcGIS service account or the run as account with which the ArcGIS services will run on the VM machine. Once I have provided all these options, I click Next. Next, Cloud Builder will ask you to specify a storage account to store the deployment artifacts generated based on your inputs, and will also help in triggering Azure deployment operation on these artifacts. This is a requirement for a Cloud Builder to function. You can enable Azure Monitoring, which will allow you to use capabilities like update management, machine metrics, setting up alerts, maintenance scheduling by clicking the Enable Monitoring using Azure Monitor logs. You will need to point it to an Azure Monitor log workspace. You can also choose to harvest ArcGIS server logs to Azure Monitor by clicking and checking the checkbox below, allowing you to enable workflows around troubleshooting, monitoring, and security compliance of your ArcGIS applications. Next option in Cloud Builder will ask for a storage account which you would like to use with ArcGIS deployment, server config store, and the portal content store. You can either choose to put it on a file share VM, or you can choose one of the Azure storage options, the Azure Files or the Azure Blob Storage. If you choose one of the latter, then you need to select a storage account again, which you can either choose to create or reference. For the purposes of this demo, we'll use a file share VM. Finally, you are presented with a summary screen which you can review and save the summary to a text file. You can also choose to generate a cost estimate or save the automation artifacts in a zip format, which an advanced user might use to integrate with his CI/CD pipeline with or without modifications. Once you hit finish, it should start your deployment on Azure, and you should have fully functioning base deployment in 1 or 1.5 hours time. Now coming back to the second screen in this workflow, where you selected the single tier deployment model. Say you now have decided that you want workload separation and wanted to spread all the ArcGIS components across multiple machines. You will uncheck the single tier deployment checkbox. Navigating forward under machine options, you will notice a few more options that have popped up. Here you can choose to tell the Cloud Builder to either pick the default names and sizes for the machines, or if you want to be more specific about the names and the sizes of individual machines, select the latter option. If you choose the latter option, you will see a new screen show up in the workflow after the data store options. This screen will tell you what all machines Cloud Builder will provision and the names and sizes associated with each of the tiers. Some of the operations you can do is to modify the names, the size of each of the machines in the tier, etc. Once done, click Next. Everything remains the same, and you observe that on the summary page, now you don't have two machines and instead have many machines in the multi-tier deployment. Now say I'm set up with my base deployment. I can publish my feature services, map services, etc. But now I need to deploy a specialized role-based server, or would like to have some workload separation by deploying a general purpose GIS server. For the purposes of this demo, I will select to deploy a GIS server. Most of the workflow will remain the same. You will see a new screen pop up in your workflow where you will be asked whether you want to create a standalone GIS server or federate it with an existing base deployment. If you choose to federate it with an existing base deployment, you will be taken to the machines option page, skipping the SSL certificate options and the virtual network options, which will be auto-populated. Alternatively, if you choose to select a standalone GIS server, the workflow is pretty similar to what you have for a base deployment, where you have to specify networking options and the SSL certificate options. Moving forward, you will be presented with the option to register a geodatabase instead of the data store options that is available to you in the base deployment workflow. Cloud Builder provides 4 different options: Microsoft Azure SQL, Microsoft SQL Managed Instances, Microsoft Azure Database for PostgreSQL, and the SQL Server on a VM. You will be asked to specify a database server and a database which you can choose to create or reference. You will also be asked for a database admin user and a database user that will be used to wire up your geodatabase server site. Clicking Next, I'm taken to the license and credentials page. On this page, you will see that the portal license is no longer required. You can also choose to specify the server site context with which your site will be federated or deployed in case of a standalone server site. Rest of the workflow is same as that of the base deployment. On the summary page, you will now see that your server role has been set to GIS server. Clicking Finish should deploy your server site within the next 30 to 35 minutes. Coming back to the catalog page, as for the V1 sites, I want to reiterate that you can still upgrade them and manage operations such as manage machines in site, add data store machines, add server machines. If it's a standalone V1 site, add or register a geodatabase, change SSL certificate, or RDP to that deployment is still available to you. That's it for the demo from me. I'll hand it over back to Nikhil for automation concepts.
Thank you, Shailesh, for that demo. So as he mentioned, there's three basic steps to getting started. The first one is you'd get an Azure subscription, of course. You'd use the one that your enterprise already has. Second, you'd get the ArcGIS Enterprise software licenses from Esri or your Esri account website. And third, you'd get the ArcGIS Enterprise Cloud Builder, which is a free download accessed from available through this URL or from the Esri site. Now let's switch gears and talk about what's new at the ArcGIS Enterprise releases 10.8.1 and 10.9. In 10.8.1, we added new functionality and support for the upgrades of both version 2 and version 1 deployment architecture. Earlier in this presentation, I went into depth about the two architectural differences and being able to upgrade your software across releases. I will call out here that upgrading from a version 1 architecture to a version 2 doesn't change your deployment architecture. It only upgrades the software bits to the latest version of to which you're upgrading. So just keep that in mind. Second is we added support in the Talcache data store for what's known as the cluster mode and the primary standby mode. And this is where you can decide either to operate two machines in a primary standby mode, or you can have a fleet of machines representing a cluster. We also added support for auto shutdown. If this happens to be a deployment in a dev environment or non-production use case where you need to shut down the machines at certain hours, this is a feature that was built for you. For the recent 10.9 release, which you should have in your hands in a few weeks' time, we added support for mission server deployments. Mission server is another server role which is federated with your base deployment and provides functionality that is specific to that server role. I'd like to call out one change that Cloud Builder enforces now in that the .NET Framework 4.8 is a prerequisite for Cloud Builder. This keeps Cloud Builder current with latest .NET Framework releases, security, and patches. Some additional features we added include you can now specify the Azure Active Directory tenant to which you are logging into. Earlier in previous releases, Cloud Builder would auto sign you into the default directory, which is typically your enterprise Azure Active Directory, and did not afford customers the ability to pick a different domain without jumping through some hoops. Another thing I'd like to call out at the 10.9 release is that geo event is now restricted to single machine deployments to match recommendations for running that server role. With that, I'd like to switch back to Shailesh to do a demo of what's new in ArcGIS Cloud Builder and talk about the mission server support.
Thank you, Nikhil. I will quickly walk you through what is new at 10.9 for ArcGIS Cloud Builder. Starting with the login experience, I click on Sign into Azure. I will be asked to select an account or enter account credentials instead of auto login in previous versions. Once you do, you will be asked to select a tenant you might want to log in, instead of being directly signed into the default tenant. Based on the tenant you select, you will be asked to select a subscription that you might have access to. Moving forward, I will now show you how you can deploy a new mission server site. I start by clicking on Deploy a new site link. On this page, where I am asked select the type of deployment I want to do, I select mission server. Moving forward, the workflow is almost the same as the one I showed in my previous demo, where I deployed a general purpose GIS server. Here, I can either choose to deploy a single tier mission server, which has the mission server and the file server on the same machine, or I can choose to deploy the mission server and this file server on different VM boxes by unchecking the single machine deployment checkbox. On clicking next, I will be taken to the federation option. Here you will see that the standalone not federated option has been disabled. The mission server requires you to federate with a base deployment necessarily. Here I select one of the base deployments and provide the portal site administrator account associated with it. Rest of the workflow remains the same, except for the mission server deployment workflow missing the register or database screen. On the summary screen, as with the other deployment workflows, you can generate automation artifacts or generate cost estimates. Finally, once you hit finish, you will have functioning mission server site in about 30 to 45 minutes. That's it for the demo. Now I will hand it back to Nikhil to provide an overview of how you can leverage automation artifacts. Thank you.
Thank you, Shailesh. That was a great demo of ArcGIS Cloud Builder tool. Let's shift gears a little bit and talk about automation and describe some concepts there. I'm sure this being the developer conference, you'll be able to relate to the need to automate things in your deployments. So we've supported automation since the 10.6 release. As I mentioned before, ArcGIS Cloud Builder is a wizard-driven deployment experience. Another way to look at it is it's also a designer to generate these automation artifacts. On the final page of ArcGIS Enterprise Cloud Builder, you will see a Save Automation Artifacts button towards the lower right. Clicking it will generate a dialog where you can save these automation artifacts to a local disk or a network share. And you can choose these different options for automation. This includes generating a Visual Studio deployment project if you are a developer, or it could be generating the PowerShell scripts if Windows PowerShell is your preference language for scripting, or you can generate cross-platform CLI scripts or the Azure CLI for doing your automation. When you generate these automation artifacts, what happens under the hood is we're generating Azure native templates and technology. This includes the Azure Resource Manager template, the template parameters fully filled out based on the inputs you provided in Cloud Builder. We provide the glue code for automation to actually spin up the ARM template in a resource group. And we also save out the licenses and the SSL certificate in the directory where it makes it easy for you to run the automation. Now, which one would you choose and why? On the left-hand side, you have the automation options such as Visual Studio, Bash, and PowerShell. On the right-hand side, we have the Cloud Builder option. And really is that spectrum and the trade-off of simplicity versus power. Cloud Builder provides you that wizard-driven experience, while PowerShell gives you the ability to customize, extend the platform. What are some typical customizations and extensibility that we see from customers? The first is if you're very particular about the name of resources, then this is an option. This is the approach you would take to being able to customize that. In the case of Cloud Builder, there are certain names that get generated, and these are defaults, such as things for load balancers and disks and network interfaces that the user experience does not expose. But using the automation artifacts, you can go in and tweak those. Another change that I hear people mostly talk about is to have more control over the network topology that their machines get deployed in. The Cloud Builder user interface limits the network interfaces to a single subnet. You're choosing a single subnet for your machines and a separate subnet for the Azure Application Gateway. With the template artifacts, you can actually go in and tweak that to use subnets and define your network topology. Along the aspect of network topology, if you need to integrate network security groups, which serve as a firewall for network traffic, if you will, as part of your deployment, this is your opportunity to do it. Similarly, if you want to integrate your deployments with other Azure constructs like Azure Monitoring alerts or via virtual machine backup policies or scheduled maintenance, you can do that. Remember, however, that if you edit these files outside of Cloud Builder, it assumes that you have familiarity with Azure and you know what you're doing, and the training wheels are really off. Now, this automation is extremely powerful, and we have customers and partners who leverage it by integrating it with various other automation technology like Chef and Puppet and Ansible, PowerShell, and a variety of these automation tools. One more experience that we have seen customers use is the Azure Cloud Shell, which is a shell that runs within the Azure portal and provides a single signed on experience and a scripting environment for you to run these. With that, I'll switch back to Shailesh to do a demo of automation and looking at the Azure Cloud Shell experience as well. Over to you, Shailesh.
Thank you, Nikhil. As Nikhil said, being able to automate your deployments can open a lot of doors for advanced users. One such door is the use of ArcGIS Azure Templates provided by Esri on GitHub. These are being provided since the 10.7 release. These templates form the backbone of a Cloud Builder GUI experience. In this repository, you will find the ARM templates, the helper scripts, the sample parameter files for each of the releases since 10.7. There is also a wiki that is provided to you in the wiki tab for you to get started. For the purposes of my demo, I will be using the Azure Portal's Cloud Shell experience. In this experience, you can either choose to work with the Bash experience or the PowerShell experience. For the purposes of this demo, I will use the Bash experience. I start by creating a folder so that we have a nice working directory to work off. In here, first I will clone my ArcGIS Azure template repository and navigate to the Windows release folder for ArcGIS 10.8. We do so since 10.9 is not yet available. Though it becomes available in the coming months, the experience will remain the same. In here, you will see the same set of helper artifacts that Nikhil showed a little while ago. You can find the ARM templates for each of the basic deployment patterns that we support in ArcGIS Cloud Builder in the templates folder. In the samples folder, you will find sample parameter files with some of the placeholder text you will need to fill out for each of the sample templates that we provide. To view either the templates or the sample files, you can use the Cloud Shell's embedded VS Code editor experience. For the purposes of the demo, we will do an ArcGIS Enterprise based deployment. We can use the same editor experience to edit the base deployment sample file. For now, in the interest of time, I will update the sample file with the one that was previously filled and save it. Next, I upload the server license file, the portal license file, and the certificate file. The certificate file is the same one that you will like to associate with the application gateway's front-end listener. That is the domain name of your public IP. These are required to make the templates function. Once I have the artifacts in place, I modify the permissions on the deploy ArcGIS sh to make it executable. Along with this file, I will need to provide the resource group name, the resource group location, a storage account, a container name, the name of the template file, and the template sample parameter file that I just saved a little while ago. Once I push enter, you will notice things will happen exactly as they do in Azure Cloud Builder. Starting with uploading of artifacts to the storage account and the triggering of deployment task in the Azure portal in the deployments tab. In about 1 to 1.5 hours, you should have a fully functioning base deployment that you can start using. Seeing the power of automation, some of you might already be envisioning many scenarios where you will be able to integrate the automation artifacts. We have a lot of business partners and system integrators that leverage these artifacts to deploy repeatable and maintainable deployments in their ArcGIS enterprise environments. With this, I end my demo and hand it back to Nikhil to provide some tips and tricks about deployments of ArcGIS Enterprise in Azure. Thank you.
Thank you, Shailesh, for that demo. Next, let's do a quick section on tips and tricks and troubleshooting deployments. Now, while we do our best to make sure that your deployments don't fail, there are certain scenarios where they might actually not work. Some of the common scenarios that we have seen is customers run into issues is when they try and deploy and they hit all Azure regions might not have all the required VM sizes, or they might hit quota restrictions at the Azure level in terms of virtual machine sizes or regional quotas. So make sure you have sufficient quotas increased in your Azure subscription before you deploy. Another best practice that we recommend is to use separate resource groups for each deployment. An additional prerequisite step that you're required to do is enable programmatic deployment on the ArcGIS image offer in the Azure Marketplace. In recent releases, we try and do this under the hood to ensure that you don't need to do that every time. Now, in case you did have a failed deployment, you'd first start off by looking at the deployment in the Azure portal for clues. Next, you'd examine the log files for errors. You'd look at the Cloud Builder's local log file, and then it also produces a remote log of what happened on the deployment machine. Next, another pitfall that many people have run into is you need to provide strong passwords for the Windows credentials, for the Windows Server account, for any domain accounts that you're using. Some of this is sometimes dictated by the password policy that is for in the network into which the machines are being deployed. And then next tip is try the defaults. Start with a small deployment. And once that works, move on to a bigger one. And finally, if you're still not having success, we encourage you to submit a support incident and provide the log files and the deployment summary. With that, we'd like to thank you for your time and listening. And these are our contact email. Feel free to reach out to us if you had questions or wanted to learn more of the product. Please provide your feedback for this session by clicking on the session survey link directly behind this video. Thank you very much.